I. That is what we get. So finally, after dividing by I, we know that from Ohm's law, because Ohm's law tells us that V is given by IR, that is Ohm's law. So if you have to divide by I both sides, by I on both sides, so we end up having R as being equivalent to V divided by I. So that means that the quantity V divided by I is given by R. So this means that this equation here becomes, or V out of I is R, so this equation becomes R is equivalent to R1 plus R2 plus R3. So this means that the effective resistance for resistors which are in series arrangement is given by R1 plus R2 plus R3, or we add up or we sum up the resistance of each of the individual resistors which are arranged in series. Okay, so meaning that this is the general equation. If you have n resistors in series, the effective resistance, you just add up the individual resistances of each of the resistors which are in series. So the same question is seen here. So for series, the answer to get the effective resistance, we add up the individual resistance for all the resistors that are in series. The same thing which is here, or the same method which is used here. So an example is here, find the resistance in the circuits below. So for this, you can see that the resistors are connected end to end. This one, then this, they're all connected end to end. So to get the effective resistance, we shall just sum up the resistance of each of these individual resistances. So the effective resistance will be given by 5 plus 4 plus 8, and this will be equivalent to 17 ohms. So for this one, the resistors are arranged in series, or they are connected end to end. So you just add 1.2 ohms plus 1 ohm plus 0.8 ohms plus 3 ohms, and the answer will be 6 ohms. So this is what we call the effective resistance. So basically, this is how we handle resistors which are in series. So let's look at the second category of resistors, or what we call resistors which are arranged in parallel. Resistors in parallel. So for resistors in parallel, for them, the voltage, or what we can call the PD, voltage or PD across all resistors, same. Is current which is different. So current is different across each of the resistors which are arranged in parallel. Voltage is the same, but current is different across all the resistors. So first of all, the arrangement is like this. You can see how the resistors are arranged, or how they are connected. The alternative connection, they are connected like this here. Instead of being connected end to end, they are connected side to side. So you can see that at a point here, there is what we call a junction here. There is a junction whereby the junction connects to each of the three resistors. So they are not connected end to end like in series. So meaning that the current divides itself into three. So you can see the current that is here is I. So when it reaches this point, it divides itself into three. So there is I1, there is I2, and there is I3. So meaning that the current I is given by I1 plus I2 plus I3. So, but we know it that the voltage is the same. So meaning that the PDF for the voltage through the PD or the voltage through this is V. Even the PD through this is V. Even the PD through this is V. So PD is the same across all the three resistors. So if you have to find the equation of effective resistance, first of all, from Ohm's law, we know it that from Ohm's law, which says that V is given by I multiplied by R. So if I make I the subject of the formula, I will be given by V divided by R. So we know V and R for each of these resistors. So meaning that we can go ahead and find I1. So I1 will be given by V divided by R1 using this equation here. Then also I2 is given by V, since it is the same potential difference, divided by R2. Then I3 is given by V divided by R3. So if I substitute this into this equation here, this equation of I up here, this one, if I substitute, I'll end up having I being equivalent to V divided by R1 plus V divided by R2 plus V divided by V divided by R1 plus V divided by R2 plus V divided by R3. So since they all have V, you can see there's V here, and V here. I can factorize out the V. So when I factorize out the V, I end up having V into 1 out of R1 plus 1 out of R2 plus 1 out of R3. If I divide both sides by V, this side by V and the other side by V, I end up with I out of V. I over V is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. But 1 out of V, this fraction here, which is 1 out of V, this fraction is equivalent to 1 out of R. So finally, the effective resistance, capital R, 1 out of R is given by 1 out of R1 plus 1 out of R2 plus 1 out of R3. So basically, to find the effective resistance for resistors which are arranged in parallel, we use the equation 1 out of R is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. So that is the equation that is given up here. Even if you have to check this side, it is the same equation. 1 out of R is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. So we have a case whereby if you have a case, this only works for only two resistors, parallel. So in the case where you have two resistors arranged in parallel, so in that case, the equation changes a little bit, and this only works for two resistors. I repeat, this only works for two resistors which are arranged in parallel. So for resistors which are more than two in parallel, we use this equation. But if there are two resistors in parallel, this one, because the equation is 1 out of R, is given by 1 out of R1 plus 1 out of R2, because there are only two resistors, R1 and R2 in parallel. So we shall end up having 1 out of R. When adding this, you take the lowest common multiple of the denominators. So this will be R1 multiplied by R2. So we shall end up having here, this divided by this, you get R2. So this is R2 plus R1. So finally, you end up with 1 out of R is equal to R2 plus R1 out of R2, R1, R2. So if we make this R here, if we make R, I'm meaning this R, if we make it the subject of the formula, we shall end up having R is equivalent to R1, R2. R is R1, R2 divided by R1 plus R2. So meaning that, this means that for two resistors, this implies that for two resistors which are in parallel, the effective resistance can be given by using the formula. Effective resistance R is given by the product, if I use PDT for product of the resistors, the individual resistances of the resistors divided by the sum of the resistances of the resistors. But this one here only works for two resistors which are arranged in parallel. Okay, so let's look at some of the examples where we have parallel arrangement of resistors. The first example is here. Find the effective resistance of the following circuit. So in this circuit here, you can see that we have three resistors and these resistors are in parallel. So since they are more than two, so we are going to use the formula effective resistance 1 out of R is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. So if we go ahead to solve this, 1 out of the effective resistance would be equivalent to 1 out of 2 plus 1 out of 3 plus 1 out of 4. So you know that when we are solving such type of fractions, we look for the lowest common multiple, the LCM of the denominators. So the LCM of the denominators is 12. So 12 divided by 2 is 6, 6 times 1 is 6, 12 divided by 3 is 4, 4 times 1 is 4, 12 divided by 4 is 3, 3 times 1 is 3. So finally, we end up with 1 out of R is equal to, this is 13 out of 12. So remember, we are trying to find the value of R. So you don't stop here, you go ahead and find the value of R. So you can do cross multiplication where you end up having 13R equals 1 times 12, which is 12. So finally, R, which is the effective resistance, will be 12 divided by 13 ohms. So finally, the value of R is 12 divided by 13 ohms. And we have got the effective resistance for the three resistors which are in parallel. Okay, so in this case here, you can see these are two resistors in parallel. This is another example, but in this case we have two resistors in parallel. So if the resistors are two, if they are two, this you can still use 1 out of R equals 1 out of R1 plus 1 out of R2 since they are two, or you can use the formula that we derived, which works for only two resistors. So the formula for two resistors is effective resistance. For it, it gives the answer direct. Effective resistance is product of the resistors over sum, and this is product is R1, R2 divided by R1 plus R2. This formula here works for only two resistors in parallel. If there are more than two, you go ahead and use this formula here, this one. So meaning that the effective resistance here will be product, which is 4 times 2, divided by the sum, which is 4 plus 2, and this is 8 divided by 6 ohms. So you can go ahead and calculate 8 over 6 and see the answer that you get from there. We look at another example here. This one we said for two resistors, this is the formula. So you can still use the formula here, a product over sum. The effective resistance here is product 6 times 3 divided by the sum, which is 6 plus 3. And this will be 6 times 3 is 18, 6 plus 3 is 9, and you end up having your answer as 2 ohms. Okay, so is there anyone with a question?